Hi, welcome to the course of heat transfer. In this course, let's begin with the basics of heat transfer. Every time when you learning heat transfer, one of the first questions that you commonly ask is what is the difference between this temperature and heat transfer, and also what is the difference between heat transfer and thermodynamics. Yes, you already learned thermodynamics in your previous years or previous semesters. Again, what is the necessity of learning heat transfer, as we learned already the same in thermodynamics? Yes, in this lecture, let us see what is the difference between those two. The first one, the difference between temperature and heat. Temperature is a measure of amount of energy possessed by the molecules of a substance. As I said, it is a measure of energy, and that is been measured as at the degree of hotness or coldness by sensing the by physical sense. We can say the body is hot or cold. By doing so, we just measure the temperature with respect to something. Whereas a heat is a form of energy which is in transit, which is in motion, which moves from one place to another place, one point to another point. And the temperature is used to predict the direction of a heat transfer as well. We know from the second law of thermodynamics, the heat always flows from hotter body to colder body, which means the heat transfer takes place from high temperature to low temperature. So this is the basic difference between temperature and heat, which are interlinked one to another. Temperature is the degree of hotness or coldness, whereas heat is a form of energy, and that energy transfers due to this temperature difference. Right? The symbol used for the temperature is capital T. The symbol used for the heat is a capital Q. The units of temperature are degrees Fahrenheit, degrees Celsius, or Kelvin, whereas the units of heat measurement are the joules, kilojoules, calories, kilocalories. Moving on, the next thing is what is the difference between the heat transfer and thermodynamics? You already learned in thermodynamics how much heat is transferred if some work is being given to the system, right? Our focus mainly on thermodynamics is to attain equilibrium. Equilibrium, whereas in heat transfer, we can measure how much amount of heat is being transferred along with how much time taken for the body to transfer heat through it or get the heat from another body, right? So how the heat is transferred, by which mechanism the heat is transferred, about which we are going to learn in the uh, next slides. Also, with the help of heat transfer, we can able to get the temperature distribution inside the body. At a particular point, what is the temperature after a particular time, that is being calculated with the help of the heat transfer, which is not possible with the thermodynamics only deals with what is the initial state of the system, what is the final state of the system, from one equilibrium state to another equilibrium state, how much heat is being transferred, how much work is done while the heat transfer takes place. These are all the thermodynamics discuss about. As heat transfer gives us the time relation, temperature relation with respect to heat. So to understand the difference between thermodynamics and heat transfer, let us consider the cooling of a hot steel rod that is placed in water. Now, with the help of thermodynamics, we can predict the final equilibrium temperature of the steel bar and water combination. Thermodynamics will not tell us how long will it take to reach the equilibrium condition, or what the temperature of the bars will be after a certain length of time before the equilibrium temperature is attained. With the help of heat transfer, we can predict the temperature of both the bar and the water as a function of time at a period of time, at a point of time. What is the temperature of either bar or water can be predicted or calculated with the help of heat transfer. So that is the difference between thermodynamics and heat transfer, and that is the necessity of learning heat transfer. Moving on, we have some types of heat transfers. We call them as modes, and the mechanism of such modes to takes place. We generally have three modes on heat transfer, namely conduction, convection, and radiation. In this lecture, we just learning what are the definitions of these conduction, convection, radiation, and what is the mechanism of those modes. We are going to discuss elaborately in the respective chapters of the modes later on. The conduction is defined as the transfer of heat from one part of a substance to another part of the same substance, or from one substance to another uh, in a physical contact with it, without any appreciable displacement of molecules of the systems or the substances. So the conduction may take place within the system or between the systems, but there should be some physical contact. There should be some physical contact maintained, and there should be no displacement of molecules. Any movement of the molecules is not appreciable. Then the heat transfer takes place, that is said to be conduction, and is been done with the intermolecular activity. We call it as intermolecular activity. Right? The mechanism for the conduction in a different types of materials is different. Like in solids, the conduction takes place through the vibration of the molecules, or the electron drift, or the movement of electrons. Right? Whenever the heat is given to the solid, the molecules of the solid start vibrating as they possess some energy, and these vibrations cause the molecules to transfer the same vibrations to the neighbor molecules, and the process takes place keep on until the heat is transferred through the molecules from one place to another place. Metals which have free electrons in their valence cells, they excite whenever the energy is given to those electrons, so they move up to the high energy levels where they can be able to stable there, so they left the energy and they start falling down. The energy is left to the another electrons of the atoms, and the process keep on takes place. So this is the mechanism of conduction that is taking place. Whereas in gases and liquids, the conduction is due to the collision and diffusion of the molecules using their random motion. So whenever a gas is heated, it start expanding. The molecules getting the heat, they start moving, they collide with the neighbor molecules, and this causes the heat energy to conduct in gases and liquids. Whereas convection, the next type of heat transfer. In convection, the heat energy transfer takes place due to the intermolecular due to the intermolecular due to intermolecular interaction, as well as the fluid motion, bulk fluid motion. So the convection takes place mainly due to this fluid motion, right? The fluid should move in order to make convection possible, whereas in convection there should be no movement that is been expecting, right? There is without any appreciable displacement of molecules is expecting in conduction, whereas in convection the fluid should move. The mechanism of convection takes place either due to density difference or due to bulk fluid motion, and that bulk fluid motion may be due to some external sources of energy or power. Depending on these, the convection is further classified into two types: natural convection and forced convection. In natural convection, it is the density difference of buoyancy forces that make the convection to takes place. Whereas in forced convection, we use fans, pumps, blowers, compressors, or some external power sources to make the fluid to move forcibly. So this is about a convection. Convection is a mode of heat transfer which takes place due to the bulk fluid motion and the intermolecular interactions as well, right? Next mode of heat transfer is radiation. Radiation is defined as a mode of heat transfer which takes place due to the propagation of electromagnetic waves from uh, the high temperature body or the body. If the body emit the radiation, every body is respective of its temperature, it emit radiation. But the high temperature body emit electromagnetic waves or radiation more than the colder body. The colder body absorbs more radiation than the high temperature body that absorbs. So, and one more thing, the radiation does not need any matter or medium. The electromagnetic waves, like light waves, they don't need any medium to propagate. They can propagate even through the space or vacuum, right? There should not be any physical contact, there should not be any medium to make radiation possible. So one more thing is the conduction the conduction takes place mostly between a solid and solid, and sometimes a liquid and gases, but there should be no appreciable movement. No movement is there in conduction, whereas a convection there is a should be a fluid that should present, and convection takes place between the fluid and solid, or the fluid and fluid. The fluid may be air or gas or liquid, gas or liquid, right? So the convection may take place between solid and gas, solid and liquid, or the liquid and liquid, or gas and gas, liquid gas, gas liquid. Radiation takes place between solid and fluid, whatever the body, right? This due to electromagnetic radiation, electromagnetic wave propagation, electromagnetic waves. So this is for now, these are the basic concepts of heat transfer. Thank you. బాగుంటే వచ్చింది చెల్లి.
చేస్తావా వీడియో?
నాకు తెలుసు వాయిస్ చాలా వర్స్ట్గా వచ్చి ఉంటుంది.
ఏం పర్లేదు.